Hey guys, here's an actual AP style problem, multiple choice. So give it a try, pause the video, try it, and then I'll do the solution for you, okay? So pause. Alright, so we have the limit as x goes to 0 of sine x cosine x over x, right? Alright, let me move this out of the way. So if I put in 0, of course I get 0 times 1, which is 0 over 0, so there's my indeterminate form. Now I'm going to use L'Hopital's rule. So L'Hopital's rule says take that limit as x goes to 0, but apply it to the derivative of the numerator and denominator and see what you get. So in the numerator it looks like I'm stuck using a product rule. So sine x, negative sine x, plus cosine x squared, basically, right? Cosine for derivative of sine, but then this cosine comes along for the ride, all over 1. So clean that up a little bit. What's that? Negative sine squared plus cosine squared, which is not 1, right? Because it's not plus, over 1. As x goes to 0, well, this goes to 0. Cosine squared goes to 1. Looks like the limit is 1. Let's check our choices. C. Hopefully you got C. Alright, let's do another one. Alright, take a second, do this one, pause the video, try it out, see what you get. Okay, let's go ahead and solve this one. We have the limit as x goes to 0, e to the x minus cosine x minus 2x all over x squared minus 2x. So it looks like a lot of pieces, but start putting in zeros and see what happens. E to the 0 is 1, minus cosine 0 is 1, that's 0, minus 2, 0, okay, so that's all 0, 0 minus 0. So we do have indeterminate form, so I'm going to use L'Hopital's rule. Obviously it's convenient when all the questions you know are in the L'Hopital section, but you'll just need to be able to recognize this even when they're mixed together. So derivative e to the x, of course, is e to the x. Cosine goes to negative sine, but I have another negative here, so plus sine. And then minus 2 over 2x minus 2. Let's check it now. As x goes to 0, this goes to 1, that goes to 0. 1 minus 2 is negative 1. This goes to 0 over negative 2, so what's that, 1/2? That sound right? Let's look at our choices. 1/2 is C. Okay, so hopefully you got C for that one as well. Alright, one more. Alright, so here's another one. This is I like this one. It's got a nice little twist to it. Go ahead and pause the video. Try it again and see what you get. And then I'll do it with you. Alright, so hopefully you solved this one. I'm going to go ahead and do it now and see if we got the same thing. Okay? Alright, so this one looks very weird, obviously, because you have an integral within your limit. But that's okay. Put in the 1 and see what you get. The integral from 1 to 1 of whatever is going to be 0. So you have 0 over 1 minus 1, of course, is 0. Now I'm going to use L'Hopital's rule. So that's going to be the limit as x goes to 1. Oops. L'Hopital's rule. I need the derivative of my numerator. The derivative of my integral is my integrand. That's our fundamental theorem, right? So it's only from 1 to x, so I don't need to worry about any chain rule kickers. So my derivative of my integral is just e to the x squared. The derivative of x squared minus 1, of course, is 2x, and now I can actually put in my 1. If I put in my 1, I get e to the 1 over 2, which I believe I remember is a choice, and that choice was D. So hopefully you got D. If not, again, just go back and look at the work. The derivative of this is pure fundamental theorem. The derivative of an integral is your integrand. The only time we had to worry about any little twists and turns were when this either was not just x, or if maybe these were switched and the x was on the bottom. So that's old school fundamental theorem. So derivative, then we can put in our 1, and there is your answer. You could always put it in the calculator and try to confirm it, but obviously it's going to be hard to put that into the calculator. But you could, you can put in values really, really close to 1 and try to calculate that integral out. Okay, hopefully that helps. I think you're okay to do the worksheet now, but if you do need any help, I will be around most of the weekend. And hopefully you guys will be in good shape. Okay? Take it easy. Have a good one. Bye-bye.